Now I'm going to show you how to solve simultaneous equation of one linear and one nonlinear equation by using substitution method. Okay, let's say this is the question. Solve the simultaneous equation of these two equations. Okay, we have x plus 2y equals to 4 and x squared plus xy plus y squared equals to 7. Okay, you can see here, this is the linear equation because the power of unknown, the power of variables is 1, and the second one is the nonlinear equation. Okay, so we have to start from the linear equation. Okay, so now if any, we have to choose the variable with coefficient is 1. Okay, so from equation 1, we make x as subject to a formula. Okay, x equals to 4 minus 2y. Okay, this is equation number 3. Okay, we have used equation number 1, then equation 3, we substitute into 2. Okay, so whatever x you substitute into equation number 2. Okay, so here we have 4 minus 2y squared plus 4 minus 2y, y plus y squared equals to 7. Okay, we expand this one, we get 16 minus 4 to 8, 16y plus 4y squared. Okay, y times 4 is 4y minus 2y squared plus y squared equals to 7. Okay, we simplify this one. 4y squared minus 2y squared plus y squared. Okay, the like terms. Okay, become 3y squared. Okay, negative 16y plus 4y. Okay, negative 12y. Okay, so here we have 16 minus 7. Okay, so equal to 0. Here we have 3y squared minus 12y plus 9 equals to 0. Okay, you can see here, this is quadratic equation. Okay, quadratic equation, to solve you may use factorization or completing the square or formula. Okay, but this one actually we can simplify this equation. Okay, we divide all by 3. Divide by 3, divide by 3, divide by 3. Okay, so now become y squared minus 4y plus 3 equals to 0. Okay, so apparently this one you can factorize. Okay, y minus 1 minus 3 equals to 0. Okay, so we solve, we get y equals to 1 and y equals to 3. Okay, so we have two values of y. Here we have two values of y. So of course we are going to find two values of x. So then these values of y you substitute into equation 3. Okay, so y equals to 1 into equation 3. Okay, so we get x equals to 4 minus 2 times 1 equals, so x equals to 2. Okay, so when y equal, we have another value. Okay, y equals to 3 into equation 3, so x equals to 4 minus 2 times 3, so x equals to negative 2. So now you can see here we have two values of y and we get two values of x. So finally the solution is x equals to 2, y equals to 1. Okay, x2, y1, or another pair, so x equals to negative 2, y equals to 3. Here we have another example of solving simultaneous equation of one linear and one nonlinear equation by using substitution method. Okay, this is SPM question of SPM 2019. Okay, solve the simultaneous equation x plus 2y equals to 1 and 3 over x minus 2 over y equals to 5. Okay, give your answer correct to 3 decimal places. Okay, so now here is the question. X plus 2y equals to 1. This is the linear equation, and 3 over x minus 2 over y equals to 5. This is non-linear. So we have to start from the linear equation. Okay, so from equation 1, okay, choose the variable, the unknown that the coefficient is 1. Okay, so now we choose x as subject. So x equals to 1 minus 2y. This is equation number 3. Okay, so then you substitute equation 3 into equation 2. Okay, 3 into 2. Okay, so whatever x you substitute here. Okay, so 3 over 1 minus 2y minus 2 over y equals to 5. Okay, now we have fraction here. We have to solve, we have to equate the denominator. Okay, now we have y, 1 minus 2y. So here 3y minus 2, 1 minus 2y equals to 5. Okay, so simplify. We get 3y minus 2 plus 4y. Okay, over y minus 2y squared equals to 5. Okay, so here we can simplify. 3y plus 4y is 7y minus 2. This one 5 times y minus 2y squared. So 7y minus 2 equals to 5y minus 10y squared. Okay, so this is quadratic equation. So we have to express in general form. So we get here 10y squared plus 7y minus 5y minus 2 equal to 0. Simplify. 10y squared plus 2y minus 2 equals to 0. Okay, so this one we can simplify the equation. So we can divide by 2. So over 2 over 2 over 2 over 2. Okay, so now become 5y squared plus y minus 1 equals to 0. Okay, apparently this quadratic equation you cannot factorize. Okay, so we have we can use completing the square or formula. Okay, to use formula, there is a formula you have learned in quadratic equation. Okay, so x equals to negative b plus minus square root b squared minus 4ac over 2a. Okay, but this one, if the unknown is x, now your unknown is y. So y you choose lah, you substitute the values of a, b and c. Okay, so a is 5, b is 1, c is negative 1. You substitute into the formula. Okay, but the unknown is the variable is y. Okay, so negative b, so negative 1 plus minus square root 1 squared minus 4, a is 5, c is negative 1 over 2, a is 5. Okay, so from here we can find the values of y. We may get to values of y. Okay, so which y is 0.358 and negative 0.558. Okay, so since you have two values of y, we will get to values of x. So to get the values of x, so you substitute the values of y into equation 3. Okay, so when y equals to 0.358 into equation 3, so x equals to 1 minus 2, y is 0.358, which is 0.284. Okay, when y equals to negative 0.558, x equals to 1 minus 2 times negative 0.558 equals to 2.116. Okay, so you can see here, you can conclude the solutions is x equals to 0.284, y equals to 0.358, or x equals to 2.116, y equals to negative 0.558. Okay, you can see the question asks you to give answer correct to 3 decimal places. Okay, so you have to make sure the answer must be in 3 decimal places. Okay, you can see here like this. Solving simultaneous equation of one linear and one nonlinear by using substitution method. Okay, this is another example. Okay, let's say we have 12q squared minus 5p squared equals to 2q minus 5p equals to 7. Okay, so we have one straight equation like this. Okay, so you have to construct these two into one linear and one non-linear equation. Okay, so the first one, okay, we get 12q squared minus 5p squared equals to 7. Okay, so this one equals to this one. Okay, this is equation number 1. Okay, another one you can get for linear equation, you get 2q minus 5p equals to 7. Okay, this is linear equation. Okay, so you have to start from linear equation. Okay, in this situation, we have to choose either q or p as subject. Okay, so from 2. Okay, so 2q minus 5p equals to 7. So q equals to 7 plus 5p over 2. Okay, this is equation number 3. Okay, so we already used equation number 2. Okay, so then you have to substitute equation 3 into the equation that we haven't used yet. Okay, which is equation 1. So 3 into 1. Okay, so then we get here 12, whatever q you substitute here. Okay, so 7 plus 5p over 2 squared minus 5p squared equals to 7. Okay, so then the rest you have to simplify lah. Okay, so we get 12, 7 plus 5p squared over 4 plus 5p, minus 5p squared equals to 7. Okay, you can simplify here 4, 3. Okay, we expand. So 3 is 7 squared, 49 plus 70p plus 25p squared. Okay, minus 5p squared equals to 7. Okay, we expand. Here we have 147 plus 210p plus 75p squared minus 5p squared minus 7 equals to 0. Okay, so now we have to simplify the quadratic equation. Okay, so 75 are the like terms. Okay, 75p squared minus 5p squared is 70p squared. Okay, so plus 210p, 147 minus 7 is 140. Okay, apparently you can simplify this. You can simplify, you can divide all by 7t. Okay, so here we have p squared plus 3p plus 2 equals to 0. Okay, so this one quadratic equation. To solve quadratic equation, you can use factorization, computing the square formula. Okay, apparently this one can be factorized, so I factorize. I try to factorize. Okay, so p plus 2 plus 1. Okay, so p equals to negative 1, p equals to negative 2. Okay, now we have two values of p. Of course, we will get two values of q. So these values of p we substitute into equation 3. Okay, so into 3. Okay, so p equals to negative 1 into 3. So we have q equals to 7 plus 5 negative 1 over 2. So which is q equals to 1. Okay, when p equals to negative 2 into 3, q is 7 plus 5 times negative 2 over 2. Okay, so q equals to negative 3 over 2. Okay, so the solution, okay, P -1, Q1 or P -2, Q -3/2. Okay, done.